Hey everybody, my name is Mark Smith, and this is I'm I'm interviewing. It's something I've been meaning to do for a while. Robert Kleinberg and I are on this differentiated gas coordinating council, and Robert presented this information. Actually, to let's see, who was it to actually? To
Methane Emission Technology Alliance at Stanford and many other places.
many other places. And it was quite frankly startling to me to understand this, the energy from a geopolitical point of view. So, Robert Kleinberg, tell me about your background and things like that.
Sure. Yeah. Great to be here, Mark. Yeah. So I'm Bob Kleinberg, and right now affiliated with both Columbia University and Boston University. But more to the point, 40 years in the oil and gas industry, mostly Schlumberger, where I was working on technology development and then got into fracking and the environmental aspects of fracking. The most interesting of which turned out to be methane emissions. That was the one that's kind of hardest to solve. And so since starting with Columbia and BU, I got interested in what the Russians were doing sort of in methane emissions. And, going back to the reports that both the US and Russia have made to the United Nations Framework Convention on Climate Change, the big reporting body, and just to see how the Russians are doing compared to how we're doing. So that's basically the genesis of this story. The data I'm going to show you is a couple of years old, needs to be updated, but this will give you sort of a quick start, and then later on I will be coming back with more updated information.
Excellent. Yeah.
Okay. And the full story of what I'm going to be talking about is you can find in preprint form in Earth Archive. It's number 3342. So if you have Earth Archive number 3342, you will find me. Okay. So first, US EPA method. We use the emission factor method. You might have heard of it. And the emission, just to define it, it's in the upper box. The emission factor is basically multiplying this factor that is devised by the Environmental Protection Agency. So this is the amount of leakage or venting from each source. So each device has its own unique emission factor. And then you come along and multiply it by the number of those devices that you have. And the numbers could be in the millions, right? Because we have a big industry. So this is so many tons or grams of methane per device times the number of devices. And then you sum up over all the devices that you have. Now, okay, when I say all devices, EPA tracks 250 unique, potentially leaking elements in the oil and gas industry. The table for natural gas systems is shown here. Don't try to read these numbers, but there's a similar table for petroleum systems with sort of comparable, it's a slightly smaller number of devices being tracked, and altogether it's 250 lines. And um, this is curated meticulously by the EPA. I have to say they're very cautious about making changes normally. Um, and each year they go back and recalculate for since 1990 for each kind of device. That's why there's so many columns. So the first column is 1990. The last column in this case is 2020. Uh, and so it
And they get
sort
all
of
this
keeps.
data from like when operators turn in their subpart W and things like that, right?
That's right.
Yeah.
That's right.
And they're supposed to then sort of sum it all up and report this up to the Paris Climate Accord, right? So that they can say, hey, overall, this is how we're doing, with our commitment to reducing climate change. This is one
Yeah,
of the, yeah.
this is what goes into the greenhouse gas inventory, the book you've probably seen, that's published by the EPA once a year, and that in turn is that same book is submitted to the UNFCCC, which is collects data from all the so-called Annex One, which is the big, mostly big countries.
Okay.
So anyway, this is how the US has been doing it.
Hmm.
Okay. So just looking at the reports from 2014, 2016, 2018, and 2020, again, as reported, 2020 as reported in 2022. These changes, certainly in the past, have been made very slowly and very cautiously based on new data. And there's hearings involved and webinars and so on. The whole mechanism of EPA sort of bureaucracy is involved in this. And indeed, these emission factors change very slowly. The activity factors change relatively slowly. Um, and so here's the for 4 years of reporting. Nothing much was going on. Around 10,000 kilotons of methane emissions from the U.S. oil and gas industry per year, going down slightly as time went on. Okay, let's look at the Russian Federation. They use sort of the same methodology, which was devised in the US in the 1990s. So they're using our method, but in a very much more coarse and less granular way. Instead of having 250 emission factors, they have 14 emission factors. Um, so they're not looking at every kind of device. They are looking at sort of big chunks of their oil and gas industry. Like the first chunk with one emission factor is the production and primary processing of natural gas. And another one is gas transport through main pipelines. And then oil well drilling gets a number. So this is far less granular than the American method. So 14 of them. So let's just look at their table and let's look at the results first. So here are the results on the plot is on the same scale as the one I previously showed you for the United States, 0 to 40,000 kilotons, and their numbers are going all over the place. So 2014 in blue, and then 2016, their reported emissions went way, way, way up, and then 2018 came down a bit, and then 2020 down a lot. And again, these are recomputed every year going back to 1990. So that's why you get these continuous colored lines. And so the activity factors, in other words, the number of components staying sort of roughly the same, but these emission factors being changed by a lot. So this is what they've been reporting. And okay, so how does that happen? So here's the entire table for gas. You can compare that to my slide number 1 with all those lines. And this is plotting the emission factors and how they change year by year. So this is the first column is the 214 report to UNFCCC, 215 report, and so on. The last column is the IPCC default emission factors that you can use if you want. Russia chooses not to. They have their own, which are generally a lot lower than IPCC. Some of them are higher. And what I've done here is each year where the emission factor has gone up, I code that with a blue arrow. And every year where the emission factor has gone down, I code with a red arrow. And so you can see that there's kind of lots and lots of red arrows here. And the numbers go down quite a bit. So here on the top line, for example, we're going from 1 times 10 to the minus 3 to 2 times 10 to the minus 4, down by a factor of 5. So that's kind of the Russian way of doing things. And here's the same chart for oil. And now this is the rest of the 14 emission factors. Okay. So here's how it works out on a year-by-year reporting basis. So this is the oil and gas methane intensity as reported in the 2013 report from the US and Russia, 2014 report, 2015 report, and so on. So these are current year data from a sequence of reports. So not the same as what I showed you earlier. Methane intensity shown here, it's oil and gas methane divided by liquids. This is my own definition of intensity. Liquids BOE per day and gas BOE per day in the denominator. And you can see US going down slowly year by year. Okay, that's good. And Russia, whoa, big drop, especially in the 2019 report, and which gets plotted as 2017, which is the final year reported by the report. And you can see that Russia now, according to their data, is doing a lot better, or at least somewhat better than the United States. So I took this to a congressional hearing that I was invited to testify at, showed this, and the congressman, especially the congressman from oil and gas producing states, were really interested in this and a little bit astounded and skeptical that Russia could reduce its emissions so fast and be better than us because, as you know, we claim that we are the best in the world. Maybe we are, maybe we aren't. But certainly for Russia to have their methane intensity decreased by 89% over a 6-year period, wow, gosh, hard to believe.
Yeah.
Yeah.
So my
And here I
conclusion
am.
out of this, Bob, is we got to get off emission factors because look, everybody who's been turning in subpart W doesn't believe the numbers, and the EPA doesn't believe the numbers, and nobody does. And so, in a way, Russia's like, all right, I can play that game too. I got my own emission factors, and mine are lower. What really gets interesting in the geopolitical sense is when Europe's saying, I got to buy the cleanest, I have laws that say I got to buy the cleanest gas. And on one hand, they're saying, I can't buy anything from Russia because of the war, but I got to
Mhm.
buy it from Russia because it's using emission factors, it's cleaner. So my conclusion on all this is we have to get on emission factors fast and get to empirical gas that's fully measured and meets other standards like ISCC and ISO 14067 and other ones that are out there now. Otherwise, geopolitically, we're in a world of hurt. And there's a lot of other reasons to get off of emission factors because I know clients who are making multi-million-dollar decisions based on factors instead of empirical measurement. They're clients who are estimating their emission factor WEC fees and are going to pay millions of dollars in WEC fees and so on and so forth. And plus, just having real data to be able to monitor their production shows so many more insights than, again, factors. So there's a lot of reasons. But this one, it brings a whole new, I would throw this in the category of almost a Russian hoax. or Russia is like, look at these. They're claiming these numbers, and by using the emission factors, they can.
Yeah.
So
And Mark, this is exactly what the congressman asked me, and my reply to them was exactly what you just said, that we need to rely on measurements. And even if the Russians don't do the measurements, even if we just do the measurements, then we can say, hey, our numbers are really correct and challenge the Russians to come up with their measurements used on some international standard using
yes,
internationally accepted equipment. And let's see who's better then. And that's the only way this is going to be resolved. So I'm 100% in agreement with you.
yeah. Well, Bob, I'm super appreciative of you presenting this information, and I'm going to introduce it to my audience just so they know that this kind of stuff is going on. Now, you got some contact info there, like your email and your LinkedIn and stuff like that. I'll put links to the show notes to those as well. But
Mhm.
kind of, what are some of the projects that you're working on now that you collaborate on and things like that?
Well, I've got sort of two projects that I'm just sort of finishing up. One of them is a memo with my Columbia Center on Global Energy Policy colleagues on the Manchin-Barrasso bill, which is the grand bargain that has been much awaited. Um, makes it easier to permit both oil and gas pipelines and drilling, and also makes it easier to permit electric grid upgrades, which we need to
Mm,
get to route renewable energy sort of around the country. The solar and gas,
hmm
solar and wind energy, and so on. So we've got some pretty strong arguments that this is a good thing. We have to convince the Democrats that it's a good thing. That's kind of the main target here. Um, and so that's one project. Another one, this is a little bit off topic for this audience, but I was approached by some European anesthesiologists who have a problem because their latest and greatest surgical anesthetic agent is being outlawed in both the United Kingdom and in European Union because of its high global warming potential. But what I show is that that is a extremely wrong way to look at this problem, and that these surgical anesthetics are actually not at all damaging to the client as claimed by
mm.
some. So that it's a little, again, a little bit off oil and gas, but
No, but listen,
another application.
you go to these oil and gas shows dealing with methane mitigation or whatever, and I'm increasingly seeing other players, the agriculture players, the landfill people, and for them, they're trying to catch up to where we're at, in oil and gas on, all these methane mitigation tools. So anyway, hey, bring them on. It wouldn't surprise me if, other industries start showing up because they're like, hey, you guys have been working on this problem for a while and got tools and automation and AI. Let's just find out what you guys are doing and maybe we can use it in other industries. So, hey,
And it's
Bob, super thankful for you doing this and explaining this to where even guys like me can understand. So,
great,
appreciate it.
Mark.
All
Nice
right.
talking to you.
Good talking to you.